Hello students, welcome to Unit 3 Notes, Section 9.3. At this time you can try the warm-up and pause the video, but to save time I'm going to answer this warm-up. So label the quadrants of the coordinate plane to the right. Well, here's quadrant 1, here's quadrant 2, here's quadrant 3, and here's quadrant 4. This goes in a counterclockwise direction. And it starts to the top left. All items up here are positive x comma y's. These are negative and positive, so negative x's, positive y's. These are both negative x's and negative y's, and then these are positive x's and negative y's. Okay. The next one is label the following as counterclockwise or clockwise. So when we move in this direction, this is the way a clock spins. So this one is a clockwise. And here, this one is counterclockwise. All right, so the lesson today is on rotations. Obviously, the reason why I brought into it the quadrants and your clockwise versus counterclockwise rotations. So our rotation, we're going to focus in on specific rotations like 90, 180, 270, and 360, and some vocabulary as well as there's a center for each one of these. So our objective is to draw and identify the rotation images of each figure. So drawing and identifying rotation images. If you take a look here, this is a quadrilateral PQRS. And this quadrilateral has a center of rotation right here. And what that means is it's fixed on that location or it's spinning equidistantly around that location. And so what you notice here is if I were to draw a circle and I were to make this larger and I were to center it, you would see that all let's see, that all of these vertices is not easy to do here. Let's say the center is right there. All of these vertices, like R, all right, so I'm just going to draw from R over as if this is the center. Here we are. Let's see. All right, so there's your R. Oops. And then here the center is, oops. Here we have the center at P. I'm going to try to center this as best I can. I'm going to use this line I drew to kind of help center it. We're going to make this larger and until I get to go through Q and S. So what you notice here is that this being the center, whoops, that P being the center of the circle in orange and the circle in purple, that the location of Q is spinning and the location of S is spinning as well, and they're staying on this circle. Now this isn't perfect. It is perfect in reality, but I can only do so good of a job here, assuming that I'm perfectly center. So S and Q are spinning and they stay on the circle no matter what. If I only rotate it 90 degrees, Q and S end up over here. If I do 180, they end up maybe over here. If I do 270, they end up over here. So no matter what, Q and S stay on that circle and R stays on the outer circle. And again, I think I'm just off a little bit, but I think you get the point, is that these are saying equidistant. So whatever distance S is away from P, no matter when I move that green line around, no matter where I put it, it's going to be equidistant somewhere on that circle, no matter if I go clockwise or counterclockwise. Okay? And so to describe a rotation, you need the center of rotation, which is a point, the angle of rotation, which is some type of angle. Here you see it in red or pink or whatever. And that's a positive number of degrees, and whether the rotation is clockwise or counterclockwise. So this one rotated counterclockwise. All right. We have a counterclockwise rotation that is mapped out by this right here. And yeah, and that's it. So I'll leave the nice drawing there. Unless stated otherwise, rotations in this book are counterclockwise. All rotations are counterclockwise if not mentioned. I put a big red, if no direction is specified, rotate the pre-image counterclockwise. Not only is it going to be that way for this book, it will be that for everything that we do. So if you don't see a direction, clockwise or counter, always assume counter. We like to follow the order of our quadrants. And because quadrants go in the counterclockwise direction, then we also go in counterclockwise unless otherwise stated that it's clockwise. Okay, you can use the following two rules to rotate a figure through x degrees about point R. The image of R itself, that is that R prime equals R. So this is the center of rotation. V is now moving so many degrees to become V prime. So for any point V, RV is equal to RV. So RV prime is equal to RV not prime, which means that these are just equidistant here. I don't like the way they did that. This really should be R prime V prime is equal to RV. And the measure of angle VRV is equivalent to x degrees. And that's correct. VRV, so angle VR V prime is equivalent to angle V R prime V prime. They're the same thing because the point's in the same location. And that they're both equal to x degrees, which are both equal to x degrees. Okay, a regular polygon has a center that is equidistant from its vertices. I keep saying that word, equidistant. Everything is equal distance from that rotation. Segments that connect the center to the vertices divide the polygon into two congruent triangles. You can use the fact to find rotation. Okay, so let's look at some of our rules. So here I made a nice little table. And all I want you to really do, look, I put another note here. I suggest that you memorize counterclockwise rules, then adjust the direction for each problem if needed. So you don't really need to memorize the clockwise ones. Just remember 90 degrees counterclockwise, 180, 270, and 360. And why is that? Well, let's think about this. 90 degrees, let's think about what this means. If I go 90 degrees, let's say I have a point here, and I go 90 degrees counterclockwise, and the point goes right here. How much is that clockwise? So here we have 90 degrees counterclockwise. So how many total degrees is it if I go clockwise? Well, how many degrees in a circle? 360. So 360 minus 90 is 270. So this has 270 degrees clockwise. And then if we take another look here, I don't know where I should put this. Maybe this is going to get too jumbled up, but maybe I do this one right here, and do this one right here, and I'll do this one right here. Okay, so now that was that point. Let's do another one. Let's do what does it look like when we do a 180? Oops. So 180, we're going to go 180. How far is that? Well, going in the other direction, it's 180 as well, because there's 360 degrees in a circle. So direction really doesn't matter here. Counterclockwise and clockwise are the same thing. So this one was, this was 270. This one is 180. And yep, I think you guessed the pattern by now. This one's probably 90. Yep, so let's take a look. This point, if I go 270 counterclockwise, that puts me right here. Whoops, I think I did this color. Which ends up being, hold on. Pencil went weird here, crazy, oops. Yeah, hold on. Give me one sec. Okay, so how much is it in the other direction? It is 90 degrees this way, because it was 270 this way. Okay. And then what happens when it goes 360? That will bring it exactly where it is. So it doesn't matter which direction it goes in. It is 360 one way and 360 the other way. So a 360 is a 360. Or we could say 0 or whatever. 360 is the same as 360, or 0, it's not moving. So we're able to say either one of those. Okay, so here are the rules for a rotation that goes 90 degrees. What happens is X's and Y's switch, but the Y becomes opposite. And that's just the rule, because if we have 2 comma negative 6, where does that end up? That ends up at 6 comma 2. So these switch, your X and Y coordinates will switch, and then the Y will become opposite for a 90 degrees counterclockwise rotation. For a 180, they stay where they are, but they become the opposite values. So 5 and negative 3. And then for 270 degrees counterclockwise, we flip them again, but this one, the X coordinate stays the same. I'm sorry, the Y coordinate stays the same. The X becomes opposite. And for a 180 degree, a 360, nothing happens. Okay? So these are the rules that we're going to follow, and I need you to memorize the ones that are counterclockwise. Now, if you're given a problem that says go 270 clockwise, just go if it says 270 clockwise, just go 90 degrees counterclockwise. Okay, same thing with 180, just do the same exact rule, and then 270 counterclockwise. Really, the only two you need to worry about is 270 clockwise and 90 clockwise. Just change them to be 270 counter, and then memorize that rule for 270 counterclockwise. All right, again, just memorize that rule. I put that in red there. And we're already kind of onto our, this is practice 9.3, but I'm not asking you to pass it in because this is all I found really that was relevant here. Looks like we have 1, 2, 3, 4, 5, 6, 7, 8 triangles. So it looks like that each one, if they're equidistant, 360 divided by 8, so 360 divided by 8, 360 divided by 8 is 45, right? Yep, 45 degrees, just checking. We get 45 degrees. So each one of these is 45 degrees. So when I rotate these, that means that each one of these is rotating 45. Clockwise or counterclockwise, same thing. So each one is 45. That means that G to H is 40, H to G is 45, and so on. So it says this is divided up into 8 congruent triangles. Find the image of each point or segment for the given rotation. So you're going to move 45 degrees rotation of G about Z. So we're going to see what point that actually gets that gets us to. So let's think about G, 45-degree rotation about Z. So this is about Z. So we're rotating about Z, which just means that it's equidistant from Z. So that equidistance, there we go. That's my circle. It gets me to point I. Um, 225-degree rotation of U about Z. So let's see. Let's do 45, 45, that's 90. 45 and 45 is 180. And then 225, ooh, that brings me to the same point I. So let me erase those. That would be 5 rotations. That's a very weird, it thinks it's a parabola. Okay, well, I'll leave that off, but we're going to say it's point I as well. Now let's see E. E is 315. Guess what? 315 is going to be I as well because 7 times 45 is 315. So point I again. Jeez. Let's see. Let's change this color because it's a little bit too close. Okay. 270 of E I about Z. So 270. So we're moving E and I together. So EI is this segment right here. If I move it 45, 90, 45, 90. Wait, 45, 90, 135. Hold on. 45, 90, 135, 180. Hold on. So I'm going 6. 1, 2, 3, 4, 5, 6. 6 times 45 degrees is 270 degrees. Therefore, EI goes to GH. So it's this whole segment. So G is moving, think about this. E is moving 6. E is moving 1, 2, 3, 4, 5, 6. E now becomes G. I is moving 6. 1, 2, 3, 4, 5. 6. It becomes H. So E becomes G, I becomes H, and that is my rotation of my entire segment, AI, which brings me to GH. Now I have a 135-degree rotation of S about Z. So S about Z, that's 45, 90, that's 3. So 1, 2, 3 gets me 1, 2, 3. That gets me point G. And 360-degree, let's see, 360-degree rotation of ST about Z. So ST about Z. Guess what? You bring it 360 degrees, and you're going to have this same exact line. So it's ST. It's going to go all the way around. S will become S, T will become T, and and that's it. We're good. So these are the next ones. This was your homework, was to do this CUDA worksheet, because there wasn't really any in the book work that I want to assign. So there's problems 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and the answers are here. What I'm going to do is I'm going to answer 4 of them. I picked random ones that I thought would be easy for you, easy to show a basic understanding of it. And so we can start with this. Hold on a sec. So in this problem, it wants us to write a rule to describe each transformation. So what I'm going to do is I'm going to, this is rotating from here to here. This is my pre-image. And this is my image. And the reason why I know that that's my pre-image and my image is because of the notation. Here, RST does not have prime notation, and S prime, R prime, T prime does. So what it does look like, what does it look like happened? Does it look like it moved clockwise or counterclockwise? Well, it looks like it moved counterclockwise. But remember, it could have moved clockwise. This would have been 270 degrees clockwise. And this would have been 90 degrees counterclockwise. Now, so the answer is 90 degrees is not this one, 90 degrees clockwise. It's not 180 degrees. It's not a reflection. So the last option is our 90-degree counterclockwise about the origin. So the answer for this one is D. Now, how do I know that this is right? Let's go back to our rule. Our rule is for 90 degrees counterclockwise, the pattern must follow that it's this right here, that it's x comma y maps onto opposite yx. So I'm going to write that. X comma y maps onto opposite yx. And this is for a 90-degree counterclockwise. So let's take our points. Let's just test it. Our points are R is at 0, 2, 2, 0. S is at 4, 1. And T is at 3, negative 4. Now, if it followed the rule, what would we have as a result? Well, switch them. Here's what I like to do. I like to do columns, R prime, S prime, T prime. I like to do one column at a time. So let's put Y and make it 0, opposite right here. So opposite of 0 is 0. Opposite of 1 is negative 1. And opposite of negative 4 is 4. And now let's repeat the x's and leave them exactly the way they are. So 2, 4, and 3. And let's see, is r prime at 0, 2? Well, it looks like r prime is at 0, 2. Is s prime at negative 1, 4? It does look like s prime is at negative 1, 4. And then is t prime at 4, 3? Well, it does look like t prime is at 4, 3. And so that truly is a rotation of 90 degrees counterclockwise about the origin. So now you can do the same thing for this next one. Take your points and see what's happening. It looks like I have x comma y maps onto what? Well, what happens? It looks like this goes there. So it looks like y goes in the first spot and x goes in the second spot. Okay. Well, that's not a rule. Let me keep looking. Y goes here. Ooh, y becomes opposite. Look at this one. Y becomes opposite. And look at this one. Y becomes opposite. So we got to be careful. Y became opposite. We weren't able to judge it because 0 is 0. But y is actually opposite. And x was staying the same. So this is a 90 degrees counterclockwise rotation. Okay? So 90 degrees counterclockwise rotation. So we are going to highlight this one. This is the answer. And all I'm doing is I'm making sure that I'm following that pattern and seeing what that pattern is. That's number 6. So I already did number 2 for you, number 6. You can just write what I did down, and then you can answer the other ones. I'm also going to do this one. I'm going to actually graph the image. So this is a 90 degrees counterclockwise rotation. So I'm going to use x comma y maps onto opposite y x because that's my rule for 90. You know how I remember 90 degrees counter? 90, n, 9, not n, n, n. Negative starts with an n. So that's how this starts, is negative, negative y. But that's just how I remember it. I don't know if you'll remember it that way, but you got to memorize it somehow. So here we're going to have r, s, and t. So r, s, and t. R is negative 4, 2. I'm sorry, negative 4, negative 2. S is 0, 1, and T is negative 2, negative 4. So now I'm going to apply that rule to it. So let's see. So now I'm going to do R prime, S prime, and T prime. And R prime is, again, I do columns. I don't like to do each point at its own. I do all the points at once. So what's the opposite of Y? It's going to be 2. So this goes here. Opposite of 1, it goes there is negative 1, and opposite of 4, a negative 4 goes there, which is 4. And all I do is I rewrite my x's here. So I don't change them at all. I'm switching x and y and just making the y's opposite right here, and I'm taking the x's and just putting them here. So x is just going here, and y is going here, but becoming opposite. And so now 2, negative 4, 2, negative 4 is here. S is negative 1, 0, so S goes here, and T is at 4, negative 2, which is right here. So this does look kind of weird, but it truly is a rotation. So here's my T prime, my R prime, and my S prime. And R prime was at 2, negative 4. T prime was at 4, negative 2. And S prime was at negative 1, 0. If you're wondering, they all stay on their circles. Whoops. So if we make this larger, Okay. T and R stayed on their circle, right? And they spun. R was to the left, T was to the right. R is to the left, T is still to the right. And then S is on its own circle. Whoops. Sometimes you have three circles because they're not all, all perfect where multiple points lie. And there's your S prime, which I really should put over here because it's kind of hard to see. S prime is over there on its own circle. All right, that's number 10. And your last one that I'm going to do is number 16. So you're pretty much a quarter of the way done with this worksheet. It's find the coordinates of the vertices of each figure after the given transformation. So what I'm going to do, what I'm going to do is I'm going to take a rotation of 180, which is opposite x, opposite y. I have it memorized. I'm going to take all my coordinates. So I'm going to take t, which is at -1, 0. S is at -1, 4. R is at 2, 5. And Q is at 4, 0. I'm going to perform that operation on them. So T prime, S prime, R prime, and Q prime. So T prime, S prime, R prime, Q prime. X stays where it is. It becomes opposite. So 1, 1, -2, 4, -4. 0, 4, and then these become opposite. So 0, -4, -5, and 0. And obviously the opposite of 0 is just 0. So the answer is T is 1, 0. And it pretty much narrowed it down to my answer, but let me just make sure, don't just jump to conclusions here. Make sure everything was good. Looks like T was 1, 0, S was 1, -4, R was -2, -5, and Q was -4, 0. Okay, so yep, you're going to want to finish the rest of this worksheet. The answers are all there for you. I won't be doing them out, and we're going to be starting our next lesson, which is this one. It starts off a little bit different, okay? So that's rotations about the origin and section 9.3. Okay, so finish that worksheet. Good luck.